probability rules. Okay, so the main rule that you will be asked over and over is that probability adds up to 1. We know that the probability of a certain event is 1, which means that all probabilities in a case must add to equal 1. Therefore, if we know that they add up to equal 1, the probability of something not happening is 1 take away the probability of something happening. So for example, the probability of Jill winning a raffle is 0.02. What is the probability she doesn't win? So it's going to be 1 take away 0.02. And if you think that this is really 100, because it's 1.00, take away 2, we're left with 98, and putting the decimal point back in, 0.98. The next topic is relative frequency. Now, relative frequency is simply a fancy word for experimental probability. So it is just find the probability. And the relative frequency of an event happening is the frequency, or how many times that event happens, out of the total number of frequencies. Estimation, expectation. When the experiment is repeated, e.g. 100 times, we may be asked to estimate or expect the number of times something will happen in those 100 times. So if we use that, we use this formula. To find the estimation or the expectation, it's just the probability multiplied by the number of times. And the key word there is times. Okay, the example. So a spinner is spun 20 times, so that's the total frequencies. The results are shown below. What is the relative frequency or probability of getting a 4? So how many times did we get a 4? So we got 1, 2, 3, 4, 5, 6. So there are 6 number 4s. So there are 6 chances of getting that event out of the total 20 times. And sometimes you will be expected to cancel that down, so that is 3 over 10. It says, what is the relative frequency of not getting a 4? So if there were 6 number 4s in that, that means there are 20, take away 6, which leaves me 14 that are not the number 4. So 14 out of 20, which cancels to 7 over 10. The next question, the experiment is repeated 60 times. So there's your key word. So 60 multiplied, because 60 times, how many times I will get a 1. So how many 1s are there? So there's 1, 2, 3, 4 1s. So multiplied by the probability of getting a 1, 4 out of 20. And get the answer, which is 12. Another way of doing that is to say, if my probability is 4 out of 20, what will it be out of 60? So to get from here to here, you times by 3. So to get from here to here, also times by 3, which gives me an answer of 12. Okay, moving on. Example 3. A spinner has 4 sections labelled A, B, C and D. The probabilities of it landing on each section is shown in the table. Okay, so bear in mind that probability adds up to 1. What is the probability of getting a C? So add up what we've got. So 0.1 plus 0.3 plus 0.4, that gives me a probability of 0.8. And what is 1 take away 0.8, or in other words, 10 take away 8 will give me 2. So my answer is 0.2. And we'll put this in the table. Part B. What is the probability of not getting a D? So not getting a D is 1 minus the probability of getting a D. In other words, 1 take away 0.4, which is 0.6. Next, it says, what is the probability of getting an E? Okay, there are no E's, which means it's impossible, so the probability is 0. And part D, it says the spinner is spun 200 times, so 200 times. Estimate the number of times it will land on B. So multiply the 200 by the probability of getting a B, which is 0.3. Now, to do this non-calculator, a nice easy way is to do 0.3 multiplied by 100. So you're moving the decimal 2 places. That makes it 30. Then times it by 2, which gives me 60. So my answer is 60. So just to repeat, I multiply by 100 and then by 2, which is the same thing as multiplying by 200. If it's on your calculator paper, you simply just multiply that in. Example 4. A biased dice, so remember biased means that it's not fair, so it's unfair. A biased dice is thrown. The probability that this dice will land on each of the numbers 1 to 6 is given in the table. Now the first thing that I see if I look at this, some have 2 decimal places, some have 1. It is easier to make them all the same number of decimal places. So let's add on zeros to make them all 2 decimal places. It says the dice is thrown once, so calculate the value of x. So remember, probability adds up to 1. So let's add up all the probabilities. So we have 0.25 plus 0.30 plus 0.10 plus 0.20 and plus 0.05. That gives me an answer of 0.9. Then you do 1 take away 0.9, which is 0.1. Part B. The dice is thrown 80 times. 80 times. 80 times. Estimate the number of times the dice will land on a 6. So multiply by 0.05. So by non-calculator way, 0.05 times by 10 is 0.5, then times by 8, so half of 8 is 4. Part C. Calculate the probability that it will land on a number higher than 4. It is important that you read the question. So higher than 4. Which numbers are higher than 4? So it is the probability of getting a 5 or a 6. And or in probability means add. So the probability of getting a 5 is 0.20. The probability of getting a 6 is 0.05. Add those probabilities, 0.25. Part D. Calculate the probability of not getting a 3. So that is 1 minus the probability of getting a 3, which is 1 take away 0.3, which gives me an answer of 0.7.